Applications of the Pythagorean theorem. On your way home, you walk past an open field, which measures 45 meters by 55 meters. The sidewalk runs down the length and across the width. How much further do you have to walk if you stay on the sidewalk instead of cutting diagonally through the field? Let's start by drawing a diagram of what the question might involve. So we know that there's an open field. We're going to assume this is a rectangle where we have the length of 55 meters and the width of 45 meters. We also know that there's a sidewalk that runs along two sides of the field. So right there's the sidewalk. So I'll draw these thicker lines as the sidewalk. And we want to know how much further someone would have to walk if they were to follow the sidewalk rather than cutting diagonally through the field. We're going to assume that it's a perfect rectangle so that it forms a 90-degree angle in the corners. And so then the next thing we want to do is to label our sides. So always across from the right angle is your hypotenuse, which we label C, and the other two sides are A and B. Pythagorean theorem says that A squared plus B squared is equal to C squared. And because this is a rectangle, I know that A is 45 meters because it's the same as the side across from it. And I know that B is 55 meters because it's also the same as the side across from it. And I'm looking for the hypotenuse, which is C. So then I take my calculator and I work out 45 squared to give me 2,025. And then I work out 55 squared, which is 3,025. And that's still equal to C squared. 3,025 plus 2,025 is a 50 or 50-50 or 5,050. And in order to go from C squared to C, because the measurement, the diagonal measurement is just C, it's not C squared, I have to do the opposite of squaring the number, which is square rooting the length or the measurement. So then I work out what the square root of 50-50 is, and that gives me a value of 71.1 if I was to round it to the nearest tenth. My units are meters, and that's equal to C. So if I was to cut through the diagonal of the field, it would take me 71.1 meters to get to my destination. If I was to follow the sidewalk, then I would need to calculate 45 plus 55, and that gives me 100. And my units are meters. So it says, how much further do you have to walk? So in order to find how much further I have to walk, I have to find the difference between the sidewalk measurement and the diagonal measurement. So I'm going to take 100, and I'm going to subtract 71.1. And that gives me 28.9 meters. So therefore, you would have to walk 28.9 meters further. Example number 2. A roof is leaking and needs to be repaired. The ladder you have is 4.5 meters, and the base of the ladder must reach the sidewalk 1.8 meters from the side of the house. How far up the wall will the ladder reach? So the first thing you want to do is to draw a diagram. So I'm going to say that this is the height of my house right here. So the height of my house, well, we're not quite sure. But the ladder I know is 4.5 meters. And I also know that I have to reach my sidewalk, which is 1.8 meters away. So I'm going to rest my ladder so that it reaches my sidewalk, so that it has a flat surface to rest on. And my ladder is 4.5 meters. So we want to know what the vertical height is. So I'm looking for, I'm going to call this side X. So once I've labeled or drawn a diagram, I'm going to assume that my house makes a 90-degree angle with the ground, and then I'm going to label the sides of my triangle. Across from the right angle is side C, or the hypotenuse. The other two sides are A and B. Now, because I'm looking for one of the other two sides, so I'm looking for one of the legs of my triangle, instead of using a squared plus b squared equals c squared, I can use a squared is equal to c squared minus b squared. So substituting what I know, a I'm going to call x now, so x squared is equal to c squared, which is 4.5 meters squared. And I'm subtracting b squared, which is 1.8 meters squared. I'm going to use my calculator to work out 4.5 squared and 1.8 squared. So 4.5 squared is 20.25, and 1.8 squared is 3.24. The next step I need to do is to subtract those two measurements. So 20.25, take away 3.24. That gives me 17.01. And in order to go from x squared to x, I need to take the square root of my value. So x is equal to approximately 4.1, and my units are meters. So that tells me that the ladder will reach 4.1 meters up the wall. So therefore, the ladder will reach 4.1 meters up the wall. Example number 3. Determine the length of the line segment in this diagram. So in order to do this, I want to create a triangle. So I'm going to draw the triangle that would be formed if I was to extend one point all the way down and one point all the way across. I know that this is going to create a right angle triangle because my lines are perpendicular. And so from here, I'm going to label the sides of my triangle. I know that across from the right angle is always C, and my other two sides are A and B. So because I want to know the length of this line segment, the C is what I'm trying to find. So in order to do that, I need to calculate what the height of A is and what the width of B is. So because my units are, my scale is going up by 1, each box is 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units high, and 1, 2, 3, 4, 5, 6 units across, or width. So I have A squared plus B squared is equal to C squared. My A is 12, so 12 squared plus b is 6 squared is equal to c squared. 12 times 12, or 12 squared, is 144. 6 squared, or 6 times 6, is 36. 144 plus 60, or 36 is 180. That's equal to c squared. And to go from c squared to c, I have to take the square root, because that's the opposite of squaring a number. And the square root of 180 is approximately 13.4. I have no measurements in terms of like meters, centimeters, and so on. So 13.4 is equal to c. So that is the length of my line segment. Example number 4. Carpenters use a 3, 4, 5 triangle to ensure corners are square. So that means that they meet at right angles, so 90 degrees. Use Pythagorean theorem to show why this works. So we're going to draw a triangle. And one side is going to be 3, one side is going to be 4, and we know that our hypotenuse has to be 5 because it's the longest side of my right angle triangle. So I want to show that a squared plus b squared is equal to c squared. So in order to do that, first I need to label my sides. So across from the right angle is hypotenuse, which is c. I'm going to label my 4 as a and my b as 3. So I want to show that the left side of this equation is equal to the right side of this equation. So if I was to split this equation up from the left side of the equal sign versus the right side of the equal sign, the left side is a squared plus b squared. So my a is 4, so 4 squared plus 3 squared, because b is 3. 4 squared is 16, 3 squared is 9, and 16 plus 9 is 25. So in order for this to work, I have to show that my right side is also equal to 25. So the right side of my equation is c squared, and the value of c is 5, so 5 squared, and 5 times 5 is 25. So because my left side equals my right side, then this works. So left side equals right side, therefore a 3, 4, 5 triangle is correct. If you have any questions about this lesson, please reach out to me, send me an email, and I will see you in the next lesson.